Here, calorimetry question number 7. 1 kilogram of ice at 0 degrees centigrade is mixed with 1 kilogram of steam at 100 degrees centigrade. What will be the composition of the system when thermal equilibrium is reached? Latent heat of fusion of ice 3.36 into 10 to the power of 5 joule by kg, and latent heat of vaporization of water 2.26 into 10 to the power of 6 joule by kg. In this question, given when ice at 0 degrees centigrade is mixed with steam at 100 degrees centigrade, but here both the masses are equal. After attaining the thermal equilibrium, we want to calculate what is the composition which is present in that equilibrium condition. So to answer this one, first of all, we have to obey the principle of calorimetry. Heat lost by hot body is equal to heat gained by cold body. So to answer this one, first of all, what are the given content is present in the problem? Mass of ice, that is 1 kilogram. Temperature of ice is 0 degrees centigrade. Latent heat of fusion is given 3.36 into 10 to the power of 5 joule by kg. And specific heat of water 4200 joule by kg Kelvin. And here steam. Mass of steam is given 1 kilogram. Temperature of steam is given 100 degrees centigrade. Latent heat of vaporization 2.26 into 10 to the power of 6 joule by kg. So here, to answer this one, first of all, we should have an idea. First, whenever we are taking ice at 0 degrees centigrade is mixed with steam. First, what happens here? Ice melts, then convert into water. Then afterwards, due to the heat of the steam, then water gets evaporated. This is the condition. So first of all, we will follow the principle of calorimetry. Here, heat lost by hot body, but which is the hot body here? Steam, and is equal to heat gained by cold body. Which is the cold body here? Ice. Now listen, heat lost by the hot body, that means lost by the hot body is nothing but giving the heat. So that's why Q is equal to M into latent heat of vaporization, that is steam, and is equal to, first of all, ice. What happens here? Ice converts into water, then afterwards water gets heated. So here mass and latent heat of fusion plus Ms delta T. Now here, this is mass of steam and latent heat of vaporization, mass of ice, latent heat of fusion, and mass of ice and specific heat of water, and rise in temperature, that is 100 degrees minus 0 degrees. That is 100 minus that one. Temperature of steam minus temperature of ice. Now I am substituting the values. Here mass of steam, that is utilized to convert the water, that is converted water from ice. We have to heat that one. This much amount of steam is required. That we want to find mass of steam into latent heat of vaporization, that is 2.26 into 10 to the power of 6 is equal to mass of ice, that is 1, latent heat of fusion, that is 3.36 into 10 to the power of 5 plus mass of ice 1, again 4200 into 100. Now here what happens? Mass of steam into 2.26 into 10 to the power of 6 is equal to 3.36 into 10 to the power of 5 plus, here I can write like this, 4.2 into 10 to the power of 5. Now here I want to calculate mass of steam which is left, that is equal to 3.36 plus that one. So here 7.56 into 10 to the power of 5 divided by 2.26 into 10 to the power of 6. But here mass of steam which is left over, that is how much amount of mass of steam is left, that is composition, is equal to division of 7.56 divided by 2.26. This one we will write as 3.3451 into 10 to the power of 6, 5 minus 6, that is 1. So here 1, that is 1, minus 1. Here 5 minus 6 minus 1. So here mass of steam is equal to 0.3345. This is kilograms. But I want the answer in grams. So that's why division with 1000 we will get 3 here 4, that is 5 grams. 335 grams. But which one we want to calculate here? How much amount of water is present? So here this steam is mixed with water to the water. So that's why here I want to calculate the mass of water at equilibrium condition is equal to, actually the mass of water how much given? 1 kilogram plus, that is 1 kilogram is given, but how much amount of steam also contained in it? That is 335 grams. But here what happens here? 1000 grams plus 335 grams, that is 1335 grams, or otherwise in kilograms division with 1000, 1.335 kilograms. This is the solution for question number 7.